So, mic on? Yes. All right, I think we can start now. So first of all, I want to introduce myself. I'm Marc HEHMEYER. I'm the CTO of Fish Labs. Fish Labs is now in its 8th year. We were founded 2004, and last year we did a major milestone in our company history. We released our first game, not only on the mobile platform, it was on the Mac. We released Galaxy on Fire 2. And when we released it afterwards, we thought, what kind of company are we now? Are we still a mobile game developer? Are we a game developer? And what's a mobile game anyway? And when I had the topic here come to my mind, I said, okay, maybe I can share you some thoughts about it, what we think, what's a mobile game anyway. All right, so let's get started. So, what's a mobile game anyway? So what is the normal definition of a mobile game? So I thought about it, and what comes to my mind, I looked it up, and the first place is Wikipedia. So what does Wikipedia say? What is a mobile game? So the first sentence there is a mobile game is a video game played on a mobile phone, smartphone, etc. I said, all right, this is a sentence I can live with. It's in every aspect true, although a calculator is not so in our scope currently, so we skipped it. So, but then another sentence struck me in the Wikipedia article, and this is this one. Mobile games tend to be small in scope and often rely on good gameplay more than flashy graphics due to the lack of processing power of the client. This was edited in August 2005, so now 7 years now. And what really strikes me, what's wrong with this from our perspective is that it's small in scope. This is definitely not true, especially for our games. Flashy graphics due to the lack of processing power of the client. This is definitely not true anymore. Back these days, yes, there were like the sentence before, a calculator doesn't have so much horsepower in it, but nowadays we have iPad 2 out there, other tablets out there, quad cores, dual cores, whatever, you name it, and this sentence is not right anymore. So but one sentence definitely is right, it's good gameplay. So let's stick this. All right. Just to give you an example why this is not anymore the truth about the performance of these devices, I want to share you some slides about the evolution of the hardware. Now with a CPU. Last year I made a speech here at Casual Connect. I presented the same slide, and I wanted to share it again, just to show you where we are currently. Just to give you an example, where are the normal consoles, PlayStation 1, PlayStation 2, Xbox 360, and Xbox 360 is the same as PlayStation 3, horsepower-wise. So these are the numbers. And now, what is the evolution of the mobile devices there? So we are currently in the middle between a PlayStation 2 and an Xbox 360 with a PlayStation Vita. Nobody knows exactly how much horsepower is it. It can theoretically run on 2 gigahertz, but I just wanted to give you this slide just to show you that we are finally nearly there, that we have console quality, and that this curve won't go much higher. Like I said before, it's more about now quad cores, dual cores, and so on. So the gigahertz will stay the same, but you will see more CPUs in the mobile devices. So this was the CPU, now comes the GPU. We had a close relationship with NVIDIA, and NVIDIA shared their roadmap to the audience, and I wanted to share it with you as well. So when we see the roadmap of the NVIDIA Tegra chipsets, in 2010, the Tegra 2 was announced. This is a multiplier of 1, and they want to achieve a 75 multiply in performance in 2014, and with the same power consumption. And this is crucial for the mobile devices. Power consumption must be very low. So 75 times faster than the Tegra 2. So this is quite a curve, I think. So this is just to give you an example what kind of environment you are seeing when you're targeting the mobile devices out there. So you can't really say, we only have flashy graphics due to the lack of processing power. So this one is flashy graphics, I have to say. This is the first Galaxy on Fire we released on Java. But since then, it was also a very famous 3D game. But to put it into a perspective, what we have achieved now is that this game is running now in an icon of an iPhone 4 on Retina display. So the same resolution we have on the J200 on the left is now an icon on the iPhone 4. So what a quite a way we did. Another one, this is Galaxy on Fire 2. We released on Java 2009. And like the curve shows you what kind of performance boost we get in the last couple of years, we could achieve the following screens and games out there. So this is the iOS version, the normal SD version currently available on the App Store. What I said before, we had a close relationship with NVIDIA, and they said, okay, we have now the Tegra 2, and it's so much horsepower in it. Please, you have a cool-looking game. Can you pimp it up and make it even more cool-looking? And we said we can do it. And then we have this kind of game. So it's all shader support with 4 times higher resolutions of the textures, 4 times more triangles in the meshes. So multi times more. Like I said, last year we released this game, Galaxy on Fire 2, on the Mac. And of course, the Mac has even more horsepower, and then we could achieve this kind of quality with all the post effects, blur, bloom, and so on. So even more graphical advancement. The funny thing is, the gameplay as such, on all iterations from Java to nowadays the Mac, is always the same. So you can even say, if you want, you can share the saved games between the Java version and the Mac version. So the gameplay as such is every time the same. Only the graphics have been improved. And of course, adapt to the different kind of control inputs. Of course, now we are wondering what kind of file size we had now. So, like I said, Galaxy on Fire 2 on Java, we released in 2009. It was 1 megabyte, so nearly out of scope. You can imagine how big it will be, but just to give you, iOS version released end of 2010 was around about 100 megabytes. The Tegra version I showed you is around about 200 megabytes, and the Mac version is now 600 megabytes. Again, the same gameplay, it's only the graphics which have been improved. So, now we come to the task we had to do to really bring this game to the different platforms. One thing is, of course, the bigger resolution we had on the small Java feature phones, 240 to 320, to now full HD and even beyond on the Mac. So what have we do to really have a cool-looking game on these platforms? First of all, the GUI elements, of course, we had to redesign and make additional sets of them. So for iPhone, on the left, you see a ship you can buy in the hangar, in the shop of the game. And on the right, it's a GUI element in the HUD inside the game where you can initiate the secondary weapon. On the iPad, bigger resolution, we have to have another set with bigger assets. And on the iPhone 4, which has Retina display, even more. What I wanted to show you here is when you think about cross-platform going to different screen sizes, you have to keep in mind when you design your assets, please keep in mind that you might target bigger or higher resolutions. And on the right, we have vector graphics so that you can scale it easily up to any resolutions you might be facing with. And on the left, this are the 3D models we are rendering out of Max or Maya, that these kind of assets are still there so that you can render it out to higher resolutions. Another one is font. The guy from BlackBerry just said some people use free type. We used a texture bitmap font. So this is the font we used for the iPhone, for the normal iPhone version. And for the iPhone 4 with Retina display, we had a different set. And this is the same set we used also for the Mac version. Just to keep you in mind, nobody wants to see this kind of typo inside the game when you run at full HD, then you can't say, what is this? So you have to make another set for bigger resolutions. Another one with bigger screen sizes, you have to keep in mind, okay, how much data or info do you put on one screen? On the iOS version, we had, for example, the status of the player divided into two tabs. On the left, it's the statistics, and on the right, it's the achievements you get through the game, the medals. And when you put this directly to higher resolutions, you get a lot of wasted space. So we thought, okay, we can combine them for the iPad and put it to one tab. So just in your game design or screen design, just make some improvements to your screen design when you target higher resolutions. So, controls. Especially when we targeted now the Mac version, we have different kind of control inputs. We are facing it. What we did, we mapped everything to our initial control set. So we have, in the iOS version, you have a virtual D-pad with the fire buttons and the virtual D-pad, and everything was mapped to these coordinates. What does it mean? On the right is the fire button and additional buttons like the secondary weapon. On the left, it's a D-pad with the boost and so on. So the first control methods we had to implement was the keyboard. Of course, on Mac you have a keyboard you want to play with. So we directly mapped these keystrokes to the analog stick and to the fire buttons. The same applies to the mouse. The movement is directly converted to the mapping coordinates on the left, and the fire button, so the left or right mouse button, is directly to the fire button. And what we also did for the Mac version, we have a gamepad support, and this is also a direct link to the analog D-pad and to the fire buttons. So this is also, you have to keep in mind when you go cross-platform, especially when you're targeting PC or Mac, how to have these kind of control methods implemented. So now comes the platforms and the technology you're facing with. So currently, we have these kind of platforms supported for Galaxy on Fire 2. From the left, iOS, Android, Migo, Symbian, Mac, and we have also a running Windows version, although it's not published currently. So what are you facing with these kind of different platforms? Of course, the code. How does the code look like? Since Galaxy on Fire 2 is purely written in native C, C++, we had to deal with different kind of wrapper platforms. This is this. In iOS, you have Objective-C, so you had a wrapper to implement to get all the touch inputs and accelerometer inputs and so on. On Android, we still stick to the Java wrapper because the lifetime management, that is, when you fire up the game, you get a suspend, you get a call, you get a battery low, and so on. You have to suspend your game and so on. And this is very easy to be written in Java. And the thing is, you can mix Java and the NDKs, the native stuff, inside Android. So the Android version is not fully C++. We have a little bit of code inside Java. Migo, I don't know who knows Migo. Migo is a Nokia platform, which you will see on the N9. It's not available here in Germany, but on other countries. We have a global preload deal with Nokia. On every N9, Galaxy on Fire 2 is installed. So there you see also C++. Symbian is also C, C++, no problem. OS X is the same as iOS, Objective-C, and C++, and Windows, you have also C++. So what kind of 3D APIs you are facing with? More or less OpenGL. This is the same across all platforms, and this is the main 3D API we are currently supporting. Only the Windows version, we have a direct export to be at the upfront. We aren't its software. I'm not John Carmack who can say to RT, please fix your OpenGL drivers inside. And so we have to convert it to DirectX to have all the problems with the latent, with the legacy OpenGL drivers. So there is a DirectX, although you can, of course, also make OpenGL running on Windows. Sound. Sound is also a tricky part because you have a lot of variations across platforms. But the main thing I want to point it out is that a lot of platforms support OpenRL. And what we also used in Galaxy on Fire 2 is a middleware solution. It's called fmod. It's very famous on consoles and other AAA titles. And when you have OpenRL and they support it, it's easily to bring it over to other platforms. So we are nearly on every platform we supported it. We have fmod in place. Only on Migo and Symbian we had to implement our own sound implementation. Texture compression is also one thing you have to keep in mind. There are a lot of different GPUs out there, and every GPU vendor has his own texture compression format, and you have to deal with it, especially on Android. On iOS, you have always the Imagination Technology GPU in place. There's PVRTC, but on Android, you see every kind of texture compression out there. And since we are heavily texture, we have great textures, you have to use texture compression. So when you have a tool pipeline, bring out every texture in different kind of texture compression formats to support every platform out there. Controls, like I said, nearly the same on the mobile devices, but only on the Mac and on the Windows we have this different kind of controls. So this is the more or less cover everything we had to do technically to cover all the different handsets, besides the layout and everything I talked about earlier. So we at Fish Labs have I suggest the following opportunities on different platforms we currently supporting. On the right are the installs we are currently facing on the different kind of platforms, and on the upper side it's the revenue. And here you see more or less what we are dealing with. On the left, on the lower left, it's Migo. Migo is, of course, only one device out there. Maybe Nokia comes up with another one, we don't know. But currently, there are not so many devices out there. Windows, like I said, have not been launched yet, but we hopefully have a decent revenue out of it, because there are so many devices out there running Windows. So this is just to give you a feel what you might get out of the different platforms revenue-wise. So, to summarize it up, what's a mobile game anyway, from a Fish Labs point of view? It's not about the platform. What I said a couple of times, on every platform, it's the same game running, only adapted to the specific behavior, controls, and so on. So it's not about the technology. Every time, it's the same game running. So when you talk about the mobile game, it's not about platform, it's not about technology. It's all about the gameplay. The gameplay has to be good enough to fit on different platforms. When you have a good gameplay, you can run it on any platform you want. And this is the last sentence. I think, or we think at Fish Lab, that popular mobile games can succeed on any platforms out there. When you have a good gameplay and you have a good technology toolchain so that you can support different platforms, you can succeed on any. There are a lot of games out there who we will see come from the mobile space and succeed on the classical platforms. And we think that for us, it's easier to scale up because we come from a small screen, we come from a small space, and we can deal with bigger screens easily and adapt it. But I think it would be complicated to scale down. For example, a World of Warcraft on a mobile device might be not a good fit. So it's easier to scale up than vice versa. And that's it. Thank you for listening. My name is written down there. When you want to contact me, our website, our Facebook site. And hopefully, some of you have additional questions for me. I am happy to answer. Thank you.
Thank you, Mark. That was great. So, do we have questions? I know I have some, so come on, someone beat me to it. Here we go, right at the back there. We have a question there. Any more, so we know where you all are? I'll find some more questions out if you don't mind.
Okay, so quick question on the chart where you showed the revenue versus installs. It seemed that Android was pretty up to par with OS X as far as revenue goes. Is that proportionally accurate, or?
It's just to give you a hint where it is. It's not absolutely accurate. I just put it on to give you a feeling what we currently facing revenue-wise on the different kind of platforms.
Okay, thank you.
Any more questions out there? Well, I'm going to ask one anyway. So when you look at the sort of console game market, you see as new platforms arise and the complexity and the depth of artwork required changes, the cost of development changes dramatically.
Yes.
And as well as that, you're dealing with multiple platforms. So does that not make it more and more difficult to have small studios be able to create games of the kind of quality that you're trying to achieve?
Of course, when we talk about Fish Labs games currently, Galaxy on Fire 2 was a 1-year development to bring it from Java to the native platform. So and the additional assets, for example, to bring over the assets to the Tegra 2 version costs us about 4 man-years of additional artwork. So this is quite an amount of money. But this is Fish Labs games, so when you have another more simple game which might be not so heavily artwork-wise, then it might be easier. If the toolchain is right, that you can support different platforms.
So the next question that comes to me is that, are we Are we seeing you guys sort of show us the way towards the mobile becoming the new console?
Definitely. Like I said, maybe I can set the answer to the question we had. We are still a mobile game developer because we think mobile will be the dominant platform in the future. Console, there will be an Xbox 7020, there will be a PS4, a PlayStation 4, but that's it. I think the days of the classic consoles will be over because mobile rules them all.
Or is it a cloud service? But then we get into a different argument.
Yeah.
I probably ought to sort of highlight, I think Phil Wright from NVIDIA's around as well. So the stuff that I've seen those guys doing on that technology it's fantastic. But I suppose I am biased. I used to be an evangelist for them for a while. So anyway, thank you very much. Thanks everybody. Cool. So next up is actually quite exciting for me. Oh, sorry, Karen. Yeah.